Hey, happy Tuesday. We've got a little bit of AI, a little bit of OpenTelemetry, a little bit of this, a little bit of that. You're watching Techstrong Gang. Hey, everyone, it's Alan Shimel. As I said in the opening, we got a some this, some that kind of menu today. I'm joined, well, no one here locally in our Techstrong headquarters in Boca Raton. Everyone's on the road. I'll be on the road soon too. But we're joined today from their homes. Let me introduce who we have. First of all, from Alabama. He's only home for a short time. He's probably about to hit the road too. Our resident expert on cloud, DevOps, AI, and everything else in between, my friend John Willis. Hey, John, welcome.
Yeah, I guess a jack of all or a master at none.
Well, that depends on your point of view.
There you go.
Absolutely. I'll take a little bit of Jack over of
there
John than a master of probably a lot of other people. And then joining us from San Angelo, Texas, near Abilene, Texas, our own editor for Techstrong AI and Digital CXO, Amanda Razani. Hey, Amanda, how are you?
Hello, good. Glad to be here.
Good to have you on. So as I said in the opening, we got a little bit of this and that, as they say down in the islands. We are going to start off with some AI kind of interesting news. And this comes from an article up on Techstrong AI, Apple and Microsoft pushing LLMs to the edge. And truthfully, it's more SLMs than LLMs. But, we spoke about this on an earlier Techstrong Gang, I think it was last week, about one of the ways of combating the huge energy cost of doing AI in the cloud or in data centers is pushing the AI to the local devices, to the edges, if you will. But of course, do the local devices have the horsepower to run the AIs? Seems like Apple and Microsoft are trying to enable that. John, this can get rather technical. What do you think? Do we foresee iPhones running AI right on the phone?
Yeah, I think, the iPhone thing is interesting, but I think more about like the real sort of solutions will be edge-based, right? Where we can put models in shipping containers next to stadiums, right? Like that kind of stuff that, where you can put shipping containers near hotspots. And, so the edge, obviously everybody's excited about iPhones and sort of some form of a chat GPT on an iPhone. And yes, but more interesting is, how do you use this technology for all the other things that are going on? There's always talk about sports betting in a game while they're playing baseball, so you can literally bet on a pitch right? And so the idea without AI is really just to put sort of shipping containers near the stadium, get a lot of power that you'd need for 30 or 40,000 people making bets. If you wanted to integrate AI and stuff like that, you'd need to put on the edge some models, right? And so I think that, the same thing applies, like small language models that may work on phones or may work in shipping containers that are unmanaged, that don't require, like the complex management of GPUs, right?
They put the pitching clock in. I don't want to see betting on pitches. The pitches are under the gun enough as it is.
I hear you. No, but you do this with your kids, I'm sure. When they were younger, sporting, you'd bet like, is he gonna, who's gonna hit
ball curve? No.
Yeah, all that stuff.
Yeah, my son, my older one, was a baseball freak, so we would have those discussions in between.
Oh yeah, no, I've had, not to go too far in this conversation, but I think at one time my youngest son was down about like $5,000. He never would pay it, but he kept going double nothing.
Yeah, it's easy when you don't have to pay.
Yeah, when you don't really have to pay. But yeah, no, grown-ups and that's just one example. Autonomous vehicles. I mean, just so many different things that require a lot of complex logic on the edge. And I think that whole idea of a small language model, and the one thing I think I feel like I'm a broken record, but I think people conflate the training versus the inference. We talked about this last time, right? And they're both distinct, but it's inference where when a model's built, it's all about inference, right? It's not about training. So again, I think the running these small language models on the edge, wherever, hotspots, different sort of locations, will not require large farms of even GPUs for inference. And then you get into the cooling, you get into the one other thing I think is interesting about small language models is I think there's two ways to augment this. We talk about retrieval augmentation generation, right? There's vector databases, there's some other forms. The SLMs work really well for specific tasks. So they're a good marriage with retrieval augmentation. Because now what you do is you take a very specific data, you combine it with, pretty good, inference engines. Some of these engines are, a dwarf compared to like GPT-4 or the really big ones, but they have really big context windows. They have, lots of parameters, right? Which is sort of the neural network of them. So you can, if you're sort of not wanting to ask, questions about Abraham Lincoln and all this stuff, and you want to just supply your own corpus data, like a RAG, like a vector database, then you can literally get very specific data, cleaner, isolated. You don't have to run it, with like massive GPUs. You can actually, there's a security thing. It's easier to secure small language models. And then I think, this is the last thing, I don't want to hear Amanda's thoughts too, but the one last thing is I think mortals will be able to do very soon training models. So right now you really have to be an AI, like really, I've had like my friend Josephine X, try to explain it to me like 10 times now about how these things work, and they're incredibly complex. You literally have to take 3 or 4 years of learning and training. But there are tools now that are starting to make training models easier for mere humans. And then Fireworks, there's a DSPY new model out of Stanford. And so as that keeps evolving, where like reasonably smart humans can actually train models, again, SLMs become real powerful, right? Because now the idea of training a very specific model for specific tasks that are sitting on the edge that may be related to utility work. Anyway, I think the SLMs are really interesting.
Yeah, I'm seeing so many more companies. We've posted a lot of articles recently that are going the way of these small learning models for various reasons. Like you said, specific tasks. They don't need these large language models that they have to hone down to what they actually need as a company. So I think we're going to see more of that. And then I do have questions, though, on the heat side that you mentioned. I know that that's been mentioned, less compute power and reduce the heat. But is it really reducing the overall heat of the world? I mean, you're just taking this large one that's producing tons of heat. You're dividing it up so you have a little less heat, but you're just spreading it out. Is it really leaning itself towards a smaller carbon footprint? I have questions.
Yeah, I think it is though, right? Because like if I can do very specific inference, again, the training and the inference are two different things, right? Somebody's got to train even the small language model, and that's going to have a footprint, because any training, not as big as say GPT-4, but if, for example, if you could run small language models with sort of vectorized data that's very specific to say utility work or or edge healthcare. Right. I'm not sure. And I'll go out on a limb and say, I'm not sure you're going to need GPUs, because that the whole point of one of the points of a small language model is at sort of, again, I'll say at inference time, the ideal is that you don't need massive compute power. So, but I think your point is like, if all this is built and we're spreading it out and we're using compute and electricity in more places, then does it really reduce the carbon footprint? Probably not.
Yeah, that was my question.
I'll give you an analogy though too. Even doing this, Techstrong gang today, the two of you are remote. I'm here in the office. So they record me in studio, and I'm actually sitting at a table with a green screen in one of our Studio B here at Techstrong. It's a really big kind of room, and it's set up as a recording studio.
Wow, I thought that was a fancy desk and all that stuff.
Yeah, no, it's all fake, right? It's all fake. But, that gets done here, and we have a whole bunch of computers and masking and everything getting done. The two of you are remote, and we basically take your feed. Your feed gets uploaded over the net, and it gets recorded in the cloud. But it makes for problems. There's latency. We got to make sure your audio matches your video, and the words match the movement of your lips and all that stuff. We've been moving now, replacing our present recording software to, something that's more custom made for this kind of situation. And in that situation, it actually records you locally on your computer, taking the network latency out of the equation and records you, because the fact of the matter is, especially if you're on Macs with some of these new ARMs and everything else, the processors, you got enough horsepower to do that locally on your computer and lose the latency that we get from the network. I think somewhat, doesn't the same thing apply here to AI computation if we can somehow run it locally like that? Assuming processors continue to, add more, not Moore's law kind of stuff, but continue to beef up.
Yeah, I mean, it comes down to the Simon Wardley's been screaming about cloud from, beginning of cloud time, right? About the footprint of cloud and, the electricity and the power and all that stuff, right? And, so, I mean, and I think if you take the Microsofts, the Googles, the Amazons, Facebooks, right? And, there is a lot of footprint going on there, right? And the more we move to the cloud, so I think at the end of the day, I think back to what Amanda's talking about. I don't know that the real issue right now, the game was the carbon footprint, and I'm not an expert in this anymore, but the carbon footprint started to get really interesting with cloud. Then you had blockchain, your crypto, right? And that started really up the game. And now you've got, the AI, which has moved it to a whole new level. So the things that we do between sort of bandwidth and I think dwarfs and compare, the real concerns are if, we're on this freight train of AI and GPUs, and there are people, I've done some podcasts with these sort of outliers who think that there's a different form of neural networks that aren't going to require. In fact, they call the GPU processing an intellectual laziness. In other words, we've driven this, we were forced down this path of compute and
what was the path of least resistance, let's call it.
Exactly. And, they're the whole thing of matrix multiplication, all the things that happen in these sort of neural networks, these people have stepped back and said, could we do this a different way where we weren't forced down what they call an intellectual laziness or, through GPUs and everything has to be GPU based. I think that's sort of interesting. I don't know where that winds up, are they swimming upstream or, No,
I think that's the way of things, John, right? You got the revolution, which is Gen AI coming to this. And now we'll see evolution, right? Feedback loops, continuous. It's almost DevOpsing AI, right? Feedback loops, iteration, reiterate again, making it more efficient, looking at different alternatives that can get more bang for the buck, but all under the guise of this AI. So, yeah, I fully expect stuff like that to happen. I don't know if it'll mean that we're going to find a radically different approach to neural networks that don't involve GPUs. But frankly, who knows? I mean,
yeah,
smart people will be working on that.
We might be forced to do that, right? So
yeah, or find make fusion real, and then we don't worry about it. All right. Speaking of network latency going though, and whether you can do stuff on the edge, on the device, or in the data center and cloud, we're going to be back in just a minute talking about AI and networking and how AI is changing networking. But we're going to take a break first here on Techstrong, gang. We'll be right back.
Cloud Native Now is the web's leading resource for the growing cloud native ecosystem. CloudNativeNow.com is your destination for news, thought leadership, features, and webinars on cloud native architecture, Kubernetes, serverless, cloud native application development, microservices, service mesh, cloud native security, and more. Stay on the cutting edge of modern application development at Cloud Native Now.
Hey, we're back here on Techstrong, gang. Our next block is actually around an article that John wrote on Techstrong AI, and it's about how AI is changing networking. John, I couldn't think of a better person to write this article, given your history and background. How is AI changing networking? What's the point of the article? Kick it off.
Yeah, I think there's a bunch of interesting things. I've been working with a company. So Mike Dvorkin, who is the creator of ACI, which basically was Cisco's SDN, right? Like he literally did that as a spin out. They brought it back into Cisco. It basically became the core of their SDN solution. He's working with an infrastructure company where they've created this sort of holistic, you could call it this idea of composable infrastructure, right? Like one API. Because the problem you have, there's a number of problems that happen here with AI, right? Particularly if you're going to run your own infrastructure, you're going to run your own GPUs. One is you have this concept of GPU starving. We can come back to that. You have heat management, and then you have complexity in just configuring GPUs, and all this sort of how do you want to do memory sharing? So it gets it's sort of exponentially complex to manage your own infrastructure that is not only composable, like that means like AI and API to manage this stuff, right? Instead of like somebody working on the network, someone working on the storage, someone working on the compute, and then somebody trying to DevOps all that, right? As opposed to, can we have, like Mike says, calls it a single API to manage it all, right? But that's even hard with just composable infrastructure in general. Then you add GPUs alongside CPUs with shared memory, right? And even the people who configure this stuff, who are like network gurus who've been configuring, they'll tell you when you throw the GPUs in the mix, it gets even more complex. And then add more complexity, people are finding that running things like Kubernetes or KS3 or some type of rancher under the covers to manage that is a good idea. Right, because you can use the whole CRD model to do that, and then to combine that with that, it just gets like crazy.
Multi-threaded, CI/CD,
and then add in security and access and network security, right? Like think about the complexity. So, like I said, a little shout out to a company I'm working called Hedgehog, which Mike Dvorkin's part of, and so I've been working with them, and like this is crazy too. They actually keep some of their stuff at a service provider that does liquid immersion, where they put all the componentries in like vegetable oil. I know, and it's like, this is crazy stuff. But at the same time, I work with a group that every year I go to Vail and I speak to different large cap technology investors. Right, it's been something I've been doing for 10 years, and I was in talking to one of the guys that works there. And he was talking about like the complexities of heat management, heat transfer management. And he said like one of the more interesting degrees right now that like the big, the Facebooks, the Googles, they can't hire enough is heat transfer engineers. So like an old throwback. And so I did a bunch of research and I found like there's all this interesting stuff about GPU starving, the management of heat. The GPU starving, is part like how do you do sort of memory sharing? So they're bringing back the technologies like PCE and NVIDIA has the NVLink and So there's just a whole bunch of stuff here. And, sometimes I just want to learn stuff. So and I knew a little about SDN, and I was working about, software-defined networking or one API. So I just started doing some research on it. And I asked Mike, would he be interested in an article? He's like, give me as many as you got. And, and it kind of fit because I'm trying to work with this vendor to see, if you were going to build your own infrastructure with GPUs, you're going to need something that sort of masks this incredible complexity. And it's more than just saying DevOps in it or just using Terraform to do it. Because, you can Terraform a lot of things, but at some point when you're dealing with very complex infrastructure, like a Kubernetes cluster that's managing network, compute, and storage through APIs that have GPUs and memory sharing between CPU, like on and on and on. It's a fascinating if there is a need to run it. This ties in with the small language model stuff. I hadn't really thought about that. Is if there is a need, and I think there will be, like everything else we've seen, to have on-prem implementations of these AI models, which I think we all probably agree that's going to happen for security, for all these type of things. Then, this is an interesting space to be tracking.
There is, sure is. Amanda, wondering if you have any thought. I know this is kind of down in the weeds, but thoughts on this one?
Well, my thoughts are, we talk about utilizing these GPUs, and of course they can process a lot more. They have a lot more power, but aren't they going to also generate a lot more heat as compared to CPUs, which still do a lot of tasks better than GPUs in some instances?
Yeah, no, the GPUs, the definitely the GPUs up the sort of power grid. This is and then the bigger problem too is the GPU starving, is that the people, even in the most complex environments, they're getting low utilization rates on GPUs, and they call it GPU starving, because the sort of the data from CPU to memory to GPU is just, the technology is emerging, and that's why these sort of shared memory models are becoming really interesting. But then you have to manage that, and then you have to have all this sort of so it's back. But it is, from my understanding, it is the GPUs that are causing the sort of the sort of the outcry of the carbon footprint, maybe lower C crisis, maybe capital C crisis, not sure, but yeah, no, and that is, but that's why the thing that I'm it looks like I'm going to get access to a ton of service to these people, and they actually can run it in a sort of a liquid immersed environment. So I actually might have in fact, I'm probably going to invite you and your team if you want to come. The plan is at DevOps Day Birmingham
I would love
do a
it.
full demo and the guy who runs it might actually bring one of these immersion tanks, and we'll have it in the lobby. And we'll do a demo with it, knock on wood. It'll be a big deal if we can pull it. Actually run a full-blown GPU structure with some training examples, completely isolated. There are, again, I'm not an expert in any of this stuff. Like I said earlier, jack of all, expert in none. But people have told me that sometimes the actual chips start eroding. So there's still but that's over time, so this isn't a completely solved problem, but it's a really interesting problem. Back to Amanda, to maybe, and they've been doing this since crypto, right? The Bitcoin monitoring, a lot of those, that actually, I don't know if that's when it started, but that's when it got real popular. The idea that small startups that were trying to do Bitcoin mining as a sort of service provider couldn't get the power that they needed. And so therefore they started experimenting with this liquid immersion type scenarios, because that
Fascinating stuff.
That'd be really cool to see.
Yeah, it'd be a miracle if we pull it off. But
you can always take the vegetable oil when you're done with it and use it as biodiesel.
Yeah, or throw a frozen turkey in it or something. I don't know. Yeah.
Interesting. Keep us posted on that one, John.
Yeah, what they.
All right. Hey, we're going to take another break here on The Gang. We're going to be back. We're moving a little bit away from AI, I think, as we talk about OpenTelemetry and observability, DevOps, etc. Stay tuned. You're on Techstrong, gang. Hey, Alan Shimel back here on Techstrong, gang. You know, moving off of our AI and Techstrong.ai articles, we're going to next visit an article up on DevOps.com talking about a recent announcement from company Embrace about adding support for OpenTelemetry to mobile applications. But the bigger issue is, has OpenTelemetry become the de facto standard for observability in DevOps and in DevOps as well? It sure seems like that, right? OpenTelemetry is the second largest open source project for the CNCF behind Kubernetes itself, followed actually in third place by Argo. But, you know, there are so many companies that are in the observability space, for instance, that when you look under the covers, they're just using an OpenTelemetry agent, you know, porting all that data to OpenTelemetry and then building their interface and so forth from there. And that's not a new business model, right? We've seen this. I've seen it in security back in the early 2000s when most IDS, IPSs actually were running Snort under the covers. And many of the vulnerabilities solutions, scanning and remediation solutions, were running Nessus scans under the covers. It seems to be that's the same thing we're seeing here with OpenTelemetry. John, wonder what you're saying.
Yeah, I think OTel is the deal. I mean, it's the standard. You know, at least what I would call a standard. I mean, I think I don't think if you're in the observability game. You know, I did talk to an interesting company the other day that they're trying to do their own sort of AI thing, and they're sort of not using OTel, but that's a freak occurrence, right? But like OTel is the standard, and I think like there was I've been tracking this for quite a while, in that even before it became OpenTelemetry, like you had the original, Adrian Cole, right? He was like down going back. He was a JCloud, so when he was at Twitter, he was one of the main committers for Zipkin, OpenZipkin, right?
Yep.
Which was that whole idea when the service mesh, it was sort of not exactly with the service mesh, but the service mesh really exposed the capability to do distributed tracing. Mm-hmm. Netflix was doing it. So this idea that you could literally run these sort of, especially with microservices, you could run these traces, like follow the thread, like almost, breadcrumbs of things that were going on, this, and and then you had Jaeger, which then became a big part of the service mesh.
Sure.
And then they combined that in open tracing, and then at some point when they sort of talked about OpenTelemetry, I think the whole world converged in that they called the three pillars, like traces, metrics, and logs. Right. And so now, like, okay, this is what we do. We do tracing, we do metrics, and we do logs. What else is there? And it's a standard. It's an API set. So anybody who's doing anything observability is, unless they believe they have a secret sauce, they're going to support OTel. I think their secret sauce is like how they store the data, how they visualize the data, like a Datadog versus but yeah, I think it is the way you do things. And the only other interesting thing is, like, you thought you were going to get out of the AI discussion now. Sorry, bud. What's interesting is I was working on this article about what I'm calling postmodern observability, right? Like, think about the original observability came from instrumentation and, the original instrument control systems and, and then, Charlie Majors sort of really exposed this idea for monitoring, and really sort of coined the modern version of that. But that's infrastructure and applications. And then really what sort of hid under the cover was data ops. and like how do you do, and like sort of observability of data, which is sort of different.
Yeah.
Like I'm looking at the schemas. I'm looking at, like, it's other than looking at the database performance, I'm looking at things like what changes in the data and what changes in the schema. But more recently, a lot of these, and I've talked about this before, a lot of these players in MLOps were using their form of observability, which is where they're monitoring the correctness, the relevance, and hallucination management. And they're calling it observability, and rightfully so. So you're actually really now what I would call, you heard it here first, folks, a postmodern observability, which is really 3 levels, which is infrastructure applications, data, and ML ops or generative AI ops, which all fall under the category of observability. And by the way, some of the vendors in the this sort of Gen AI observability level are using OpenTelemetry, which is really cool.
Yeah.
Like, so they're like, hey, like, put your data here. You can throw it up in Prometheus. You can do all this great stuff because you're following the standard. So I think that's
you brought up Prometheus, John. It's interesting, right? To me, OpenTelemetry is very much, under the covers, the underpinnings of a lot of this. But Prometheus is no slouch either, right? And a lot of times it kind of works like this with OpenTel, right? Prometheus is also, I think, in the top 5 or 6 open source projects at CNCF. And then you have you mentioned Jaeger, another one. Our friend Jonah Cowell, of course, is one of the maintainers on the Jaeger project. Other the Grafana Labs people as well, right? To me, the real revolution or evolution here was that what we used to call the APM, application performance monitoring and management market, that had, several successful companies. AppDynamics, of course, Cisco paid billions for. New Relic, public company, Dynatrace, more. There were many great, and there still are many great APM companies out there and products. Datadog at that time too. They shifted under the covers from proprietary models of data collection to relying on triumvirate or more of open source projects led by OpenTelemetry, which you mentioned the OpenTrace kind of project, and that was married to a few other things to give us what is today OTel.
I think that's the beauty of all this, right? It is very easy for even like these new AI players to get data into Prometheus or Grafana, right? Because there is sort of a standard now. There's a way to do it. It's a way for me to sort of integrate, Dynatrace and whatever other open source. So like, this is why OTel is so successful. And again, I think the thing that really caused the conversion, and I'd love to have somebody tell me I'm wrong, because I'm up for, I'm wrong about 50% of the time. But hey, I think it was the service mesh that like was a forcing factor, and it was a convergence point where service mesh, you couldn't have all that complexity in the service mesh, that all the things that it does, without sort of having something in the middle that allowed you to sort of integrate Prometheus with Zip, whatever Zipkin's become part of OTel. All that stuff, and even traffic management and all that stuff, just required, a new architectural design that required to be sort of standard API based. And so I think that was the thing that was the forcing factor of the success of, in my opinion, OTel. As well.
I think also at OpenTel, and Amanda, maybe you remember, there was a company ServiceNow bought, it wasn't Lightel, what were it? It was the four guys who came out of Google. Not Ben Horowitz. Anyway, I'm at a loss. Amanda, I don't know if you would remember this company either. It was an acquisition by ServiceNow. These guys really helped kind of push OpenTel to what it is today. And I apologize, Rob. Sometimes I remember things, and then here and they're gone. Anyway, hey, let's move on a little bit here from the OpenTelemetry and DevOps thing. And we got a few minutes. John, what do you got going on exciting you want to share that you haven't shared yet?
Yeah, no, I think what was interesting is, I've been running a lot of hackathons and I've been learning, just watching what people come up with, right, is another sort of, for anybody who's been following me, the last year for me has just been a total immersion in trying to learn as much as I can about what this AI stuff is, how it relates. What I care about is how it's going to impact, sort of the DevOps, our infrastructure, our technical debt, all the things that are going to fall back on us. But one of the things I fell into is there were a couple of guys, prototyping this idea so embeddings are not secure. So all this stuff about like creating vectors, you can reverse engineer embeddings, right? So all this stuff, embeddings are like you take sort of words and you tokenize them and you spray them and you put them in these high dimensional spaces. And so there is some papers and research and people pointing out that like it is not impossible. In fact, it is feasible to reverse engineer embeddings, particularly if you have a box with GPUs, right? And interesting thing about embeddings is, and actually GPUs, I've learned this recently is, and again, I'm willing to get corrected here, but like GPUs in essence really do matrix multiplication. That's what they do. They literally, multiply matrices, which create nether layers and nether layers and layers, which create these deep neural networks, right? So one of the things we found out is if you take an embedding, let's say you have a chunk of data that is a description of what to do in case of, let's take a crazy thing. Like, let's say there are a set of steps you have to do to turn down a border router because you might be compromised or you might have some crazy algor going nuts, right? These are true stories, right? Like you're a large financial institution and you realize that, a night capital is happening. And so therefore there are two people that can actually shut off the border routers, right? And there's a set of procedures, almost like a nuclear sub of what you have to do. These are true stories, right? And let's say now you've got that in an LLM. Now you might say you're crazy for putting that in a little chat, but let's just say that's really proprietary data, right? And so that proprietary data is vectorized, right? So it's in this highly, maybe through a RAG or something like that, which then when I ask, hey, what do I do? Emergency, I need to turn off the guy who normally does it is not here, and I need to turn off the border routers, right? And it's going to answer that question. Again, I'll take as many hits now. If you want to say, John, you're crazy, nobody'd ever do this, that's fine. I'm just using it as a training example. And let's say that like we wanted to encrypt that data, but the embeddings are not encrypted, right? You can't really just encrypt embeddings because embeddings are basically highly dimensional fields or tokens in a vector. And the way that it finds the next word, the next sentence, the next paragraph is through similarities, like angles in the vector. So I know this is hopefully this will make sense when I get through it. What we found is if I apply matrix multiplication against the embedding vector, it will still give the same location and the same words, they'll just be encrypted words. So this is really fascinating that you can literally use the same math that they use to create the embeddings to put like some complex key on top of the embedding, which then encrypts the embedding itself. So now they're like it's going to point to the gibberish words that you've encrypted alongside of that. But now if I have a key, I can do that question. I get the gibberish paragraph back, but now I can go ahead and run my key and get the answer of what it is. And the beauty is like it's a way, it's such a simple idea that you can basically turn the embeddings into a secret by not really encrypting it, but by using the same math that uses itself.
Multiplication.
Because the locations are going to be...
Once we know that you could undo that, though, what's going to stop the bad guys from doing it as well?
Well, they need the key.
That's true. Because otherwise they
just get if you've got a 4096 key
anyway.
or if the key that you use to use the matrix multiplication, same key that you use to encrypt the data, and if you're building this stuff on a GPU, you can make the key like incredibly large.
Right.
So yeah, no, I think it's going to be an interesting conversation. I like again, somebody in a hackathon was playing with this, and then me and Joseph Enoch did a bunch of research, and like it's an emerging topic. The whole idea of like securing embeddings.
I guess the biggest thing will be safeguarding those keys.
Right.
Well, but
I would not use the same key. Probably good practice is you don't use the same key for the encryption that you would do for the
you don't have to. Yes, sir. That's a good idea.
Right, you don't. This way it's a double key system.
Really. Yeah, one is a key that just changes this consistent. Like if the distance between this word and this word, if I use matrix multiplication, it's the same distance.
Yep.
So
I don't know how many people out here we lost on that. But if you're interested, write to John about it. It's fascinating stuff as we continue. Hey guys, we're 45 minutes in. I'm afraid I have to pull the plug on this version of the gang. It was great having you both on here remotely. Hopefully we'll have more people in person later this week. I want to quickly shout out though that, this is Tuesday. We'll be back on with fresh content on the gang and Techstrong TV. Full schedule on Thursday. Next week's a big week. We are out at RSA Network Monday through Thursday, live on Broadcast Alley, as well as our DevSecOps AI event. We will also be in Las Vegas for the ServiceNow user conference, and I don't remember the name of it off the top of my head. Also this week, we are in Vegas. Mitchell and some of the team is out there for the Atlassian conference. So stay tuned for live coverage on that. Another busy week here on Techstrong TV. John, Amanda, thanks for joining me. Thank you for watching this. This is Alan Shimel for Techstrong. We're out.